Welcome to solverfy.
In this problem, we have two light sources, S1 and S2, that are radiating in phase. There's a separation between them, distance d, and we're told that d is 2.7 micrometers, and that the wavelength of the light emitted by both sources is 900 nanometers. And we're asked that if the two waves converge on the x-axis here at some point P, what is the biggest value of x? So how far along the x-axis can point P be for these to be completely out of phase? So for them to be completely interfere. Okay, so the phase in general is given as the wave number times the distance traveled. So I'm going to just call the distance traveled S. Okay, so the wave number is 2 pi over the wavelength and then times S. So S is going to be different for both of these sources here. So phase 1 from source 1, well, that's pretty simple. S is just X. Whatever X is, this is what we're solving for, is X. So we're going to have that the phase is 2 pi over lambda times X. And phase 2 is going to be this hypotenuse to this triangle here. This is a right angle. And the distance here on this leg is d. So phase 2 is going to be 2 pi over lambda. And then the distance here is this hypotenuse. So that's going to be square root of d squared plus x squared. And we want the phase difference to be some multiple of 180 degrees. So what exactly do I mean by that? So delta phi will be the phase difference between these two. So that'll be phi 2 minus phi 1. And we want that to equal pi. And then I'll put in parentheses plus 2 pi times n, where n is an integer, right? So we can be pi, or we can be pi plus 2 pi, right? So that would be 3 pi, or we could be 5 pi. All these are 180 degrees out of phase. Now, what is n going to be here for the furthest x, the largest x? Well, you can imagine if x goes to infinity, then these essentially become parallel rays. All right, so that would be, then we just move in a little bit, and that would be the first minimum. And so that would be, you're off by exactly half a wavelength. So that would be n equals 0. So that the furthest is just half a wavelength off. So we can just set this to 0. All right, so now let's just plug in. Delta phi equals, phi 2 is 2 pi over lambda times the square root of d squared plus x squared. And then minus phi 1, which is 2 pi over lambda times x. And this has to equal pi. So I'm going to put everything that's not in the square root on the other side. So first we can see that the pi's cancel here. And so this is just going to be 1. And I'm going to multiply everything by lambda. And I'm going to move this guy over here to the other side, so that I just have the square root on the left side. So I've multiplied by lambda, so I'm left with 2 times the square root of d squared plus x squared equals, this pi turned into a 1. I've multiplied by lambda, so this is just lambda. And then plus this term, where the pi's gone. I've multiplied by lambda, so it's just plus 2x. Now I can square both sides. 4 times d squared plus 4x squared equals lambda squared plus 4 lambda x plus 4x squared. 4x squareds cancel. And the only term with an x here, which is what I'm solving for, is right here. So I'm going to write that first. So I have 4 lambda x equals, here I have a 4d squared, and I've brought this lambda squared to the other side, so minus lambda squared. Dividing by 4 lambda to isolate x, I have x equals 4d squared divided by 4 lambda is going to be d squared over lambda, and then minus lambda squared divided by 4 lambda is lambda over 4. And plugging in the numbers, I'll write them again. We have that d equals 2.7 micrometers and lambda equals 900 nanometers. So plugging this in, we have that the biggest distance turns out to be 7.9 micrometers.